Tell me, please, do you see information in our chat about program course and graduating system?
Yes.
Perfect. Our topic today is decision tree. Sorry, it doesn't work. Mhm. Yeah, it's okay. Sorry, it's technical problem. 1 second. Mm. Guys, I'm sorry, few minutes. I need to check my board. Tell me, please, do you see my screen?
Yes.
Thank you. Mhm. Yeah, it works. Okay, our topic today is decision tree algorithm. It's supervised machine learning algorithm. We usually use it for classification task, but it often can be used for regression task. To be honest, decision tree is algorithm which is used in our life every day when we making decision and when we try to understand rules for specific activities. Um, Also, we usually use it some sphere, for example, banking sector or retail, when we communicate with our customers. And for example, if the customer pressed button 1, the call should be transferred to sales department. And all concept decision tree, we can describe how if some condition, then some act or some expected result. And we can um, see some example with credit scoring. When some client go to bank and tell that, hello, I want to take some money my for my life, and can you give me this money? And the bank needs to understand um, whether this customer money back or no. And for example, we have some features X1, I don't know, maybe education, X2, how old is our customer, X3 is salary, X for some other parameters. And our question, can we give money for this client? Is the main question. And we have some data about person. We can start from this data and create decision tree. What is it? How is the decision tree built? We need to define some conditions for making decision. For example, if x1 is I don't know MAPT, yes, we can give money for this person. And if no, we need to create next condition. For example, x2 more or less than 18. If less 18, no, we can't give money for this client. And if yes, we can create some new condition for checking our rules for giving money. And the main question in this algorithm, how you can divide your data the most optimal approach, or the most optimal way. And let's try to consider case. For example, when we use some squares and 4, for example, and 5 circles, and other colors. Then, sorry, we want to classify our circles with the colors, and how we can make it. For example, for every circle, we know coordinate for this circle. For example, 0, this 2, 4, and next coordinate. And we want to divide our circles the most optimal way. And when we divide it for 2 groups, we want to, one group is the orange circles, and the second group is the green circles. And it condition must be works. So how we can do it? For example, we can okay, first we can calculate some information about this station, and how we can define station. In decision tree approach, we have some metrics, some for defining our station. And the first metric is the Shannon entropy. I can write the formula. Do you know about entropy? What is it? Guys, what is
Oh,
the
we didn't have
entropy?
physics.
Repeat please.
We didn't have physics.
Oh, it's sad, but okay. Okay, entropy is just some measure of chaos, and if your um, if your system station is very undefinable, is very high entropy. But if your station very understandable, it's low entropy. I think it's uh, very simple explanation. And the Shannon entropy is very important definition for is used in physics, in theory of information, and other spheres. And how we can use it for defining entropy of our station. Uh, let's try to calculate this expression. For example, if we know that we have 1, 2, 3, 5, 6, 7, 8, 9, 10. Okay, as I understand, we have 20 circles. And let's try to calculate the probability of take green circles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it's 10 of 20s. And for orange circle is 9 of 20s. And we can calculate our entropy like minus 1, 2 log minus log 2. Okay, we just used this formula and for understanding entropy of this station. I don't calculate this, but it some approximately 1. And what we can say after we get 1? It doesn't say something new or something interesting, but we can comparing different values of entropy in every station. And let's try to divide our circles with features of feature of coordinate. We know that every circle every circle has own coordinate, and it's some x. And let's try to divide our circles with rules. With rule x less or equal 12. And we know that 12 is approximately here. And now, if we divide our circles with this condition, we, sorry, we will get that in first group more orange circles, and in second group more green circles. I can do. It's okay. 1, 2. Yes, and if we calculate this expression now, we will notice that our entropy become low, and I don't want to calculate it, but you can calculate entropy in this station, entropy on this station, and in this station, we know that almost only green circles, and it's good for us. And in this station, okay, we only have green circles, but we can try to divide our first group on next rules. And for example, we can divide this, and after next iteration, we will get a new group, this, and this. And in this group, you will get more orange circles, and this group you can make next iteration and divide with different condition. And at the end, we get some lists of our tree, some classes, and we know if new element will go on this way. We can define the class for this new element. And next, I think we can check notebook with very simple case. Let's try to import libraries. It's just sklearn, pandas, and numpy. And now we create dataset dict. Is a toy dataset with some features like temperature, wind, play, outlook, and we want to predict whether some person play in I don't remember, tennis. Yes, or no. And we know some features that can influence on this decision. So if the outlook sunny and temperature is okay, and wind falls, we can play into the tennis, play tennis. Or if we take some the bad conditions, we can't play tennis. And now we transform this dataset with helping pandas with more simple calculation, and preprocess our data. What happens this? What is the dummies? When we see in our dataset some values non-number, we need to transform this data some way. And the most popular and most simple way is just say that, okay, we know that we have some categories: sunny, overcast, rainy, and etc. And let's say that sunny is 1, overcast is 2, and rainy is 3. And just yeah, it seems like this. And with okay, sorry, we can make like I told you, for example, 1, 2, and 3. But also we can transform this data with one-hot encoding. One-hot encoding is a method when you have a vector, and when you see some values, you write the 1. If you don't see some value, it's 0. And for appropriate values in your feature, you need to write 1 if it is um, sorry, specific value. And also we need to do with these values, because we can't work with false and true, no and yes, but we can say that no is 0 and yes is 1, and y and false true analogically. Okay, we know that we have some features, and we want to predict play values. It's our target. We want to understand how we can divide our data. And to be honest, in this code, we will do the same things like this. You need to divide your data with a specific condition for every features. You know all values for specific features, for specific feature, and you can try to change some boundaries value. For example, you know that temperature is 50, 55, 59, 60, and etc. And you say, okay, let's try to divide our data with this boundary. And you try to change the most optimal boundary for dividing your data. And we try to divide our data, and next we need to calculate the measure of measure of chaos in our data. We have some ways for it. I wrote Shannon entropy, but also we have Gini, and Gini almost the same calculate like Shannon entropy, but formula more simple. And usually we use Gini just because it's more, just because it's simpler. Okay, we need to calculate Gini for all dividing, and understand how we can divide our data. In this code, we implement decision tree manually. But of course, in real life, we just use the ready algorithm from some libraries, for example, sklearn. And now I want to show you very cool visualization. Let's try to import decision tree classifier from sklearn. In sklearn, we have a decision tree classifier and decision tree regressor. And you can read in documentation all information about parameters. The main parameters we consider today, for example, criteria, splitter, max def. By the way, criterion is a way to divide your data. How you define that you divide it optimal way, and this metrics for it. And in sklearn, we have very cool visualization for decision tree training. Let's see. What is it? We know that in our data, 14 samples at the beginning. Yes, we split our train and test samples 50%, but it's not a good idea. But it doesn't mind now. And 14 in train and 14 in test. And let's try to calculate Gini on the first step. This is a condition in specific nodes in our tree. On the first step, we choose that overcast less than 0.5. Gini, our metric for this node, is 0. Yes, 459. Samples 14. Values, first value is number of first class samples, and the second value is number of second class samples. And class play, we want to class in our data, more samples class play is the most often class. And now we can divide our data true, overcast less 0.5, or no. If true, we get these new samples. And now we can create the new condition. Temperature less 77.5. And the same actions. If it's true, we get new node, and if it's false, we get only new node for false condition. And if you notice that in every node, we can calculate values of value of Gini. If Gini 0 is, it means that your data perfect dividing, perfect divides. if Gini has another value, it means that you can try to divide your data more. And also, I want to say importances features for decision tree building. So we built our decision tree, and now we want to understand which features uh, become became more important. And on this graph, you see that in dividing our data, participate only temperature and overcast. For our dividing is this feature is most important. Okay, do you understand this visualization? Guys, are you here? Okay. Um, Now we can come to next notebook, and now we want to see decision tree regressor with different depth. So I told you that in decision tree algorithm we have some very important parameters, and let's write it. First is max depth. Is depth of your tree. Max features. Number of features which we use during dividing data. And mean sample leaf. It's minimal number of sample for every leaf. What it means when you divide your data, your model try to approximate your data very closely, and you can face to underfitting and overfitting. These parameters help to fix overfitting and underfitting. It could be some regularization for your tree, and choosing this parameter value is very important for decision tree algorithm. So let's try to understand our code. In this part, we choose max depth 2 and max depth 5. Let's try to approximate our data. And on this picture, you see that the decision tree approximates the dependence of a piecewise constant function. It's some special thing for decision tree. And yeah, you see this picture. How do you think which algorithm better? With max def 2 or max def 5? Guys, what do you think?
Max def
5.
2.
Uh, I heard 2 and 5. Can you explain your opinion?
Well, I don't think it's 5 because you're falling into overfitting your
Yes,
data.
yes, it's true. Um, to be honest, if we speak about MaxDev 2, is I think is underfitting. But if we compare this algorithm, I agree that MaxDev 2 give better result. It's more greedy approximation, but on test samples, on test data, it give better result than overfitting model. So you see that your model did 5 mm, def your tree try tries to describe all data and some specific sorry, I forgot this word. 1 second. Yeah. Mm, data outliers. Yeah. So this sign function and this data samples just noise, and we want to model understand it. Okay. What about informativity criteria? As I told, is Shannon entropy and Gini index. What what is it in this expression? I can try to talk you about it. Let's see. This is number of samples for class K in specific nodes R. This specific node, and we want to calculate probability to take element of specific class. For example, like in this scenario, we calculate this value and its probability to take element class 1 meet in our data. And yes, you can. Oh, okay. What is RL and R left and right? When you divide your data on right and left nodes, you want to decrease entropy in your data, and you want to optimize this expression because you want to entropy of during station will more than entropy in next station in your data after dividing on left and right node. Okay, we can see that in binary case classification, Gini and Shannon entropy very closely on the graph, and usually we can use Gini because it's just simpler for calculating. Okay, also we have regression criteria for regression task, and you know some really prediction your target. You know some target value, and you know some prediction value, and you can calculate difference between this value, and just use this formula. Okay, now we will try to solve regression problem. We have data point, and we want to predict distance between your data point and 0, 0 point, center of coordinates. So you see these data points, and let's try to call decision tree regressor from sklearn fit or on our data, and let's try to make prediction. You see on this picture that your model try to cut space on different parts, and every part try to describe your specific data point. You want that your model has some one second generalization. One second. Oh, generalizing. Okay. Summarization abilities for your data. But in this case, you see that model try to cut every rectangle for every data point. It means that your model just overfit. So, and how we can try to fix this problem? As I said, we can play with some parameters, minimal number of objects inside a leaf, and maximal depth of the tree. We can see some dividing with some dependencies on max depth and min samples leaf. 15, 5, and 1. And with these parameters, we can control our model and try to save it overfitting. Okay, also I want to say next thing, decision tree is very instability algorithm. In this part of our code, we take 90% of data, and we want to check our algorithm for different random 90% of our data. So just we take first part 90%, then we choose next some random 90% subsamples, and try to check our algorithm. We see that dividing of our space different in three ways, but we use the same data from one data set, and it's a bad situation. We want to create algorithm for fixing this problem, and now we can discuss Ansibles is a way to save this situation. What is the Ansibles? Do you know about Ansibles? It's a really simple conception. Mm, okay, maybe you don't see about Ansibles. Um, what is it? Mm, let's try to understand it with a simple example. For example, you want to buy some things, and you have a free friend, for example, Dave, Steve, and John, and you ask, um, do you need to buy this thing? And Dave say yes, John say yes, and I forgot this person, Steve. Okay, Steve says no, but more person from your voting give answer yes, and it's more than one voice from Steve. And Ansible is a very similar conception. You need just take um, some amount of trees, and after prediction, for example, for a new sample from your for your task, you want to understand what is it. And this tree said that is a circle. This tree said this is a circle, and this tree said that is rectangle or square. But you can choose result from more more trees. And if we use this algorithm for a regression task, you also have one, two, and three tree. And for example, you want to predict price of some flat, and 1,000, sorry, dollars, $2,000, and $500. And how you can understand what's answer is right? You can just sum these answers, and divide on tree amount of your trees, and in this way you get more um, closely to target answer. Okay, is Ansible conception, but if you want to understand how it works with which algorithm in this conception we have, you need to understand some thing about bootstrapping. What is the bootstrapping? Let's imagine that you have some data, some circles, and you want to randomly and uniformly n size subsamples. You want to take randomly and uniformly n size subsamples, and you just see this data and okay, let's create some sample X, and in X we have 8 data point, and on next iteration we do the same things. You take next data and create some samples. In these samples, size n for this and for this too. So you repeat this procedure m times, and at the end of this process, you create m bootstrap samples. So you can use these samples for next algorithm. And the first algorithm from Ansible is bagging. What is the bagging? You can use your bootstrap samples, and for every bootstrap sample, you train some model. For example, you say, okay, I need to give the first decision tree and train it with the X1 sample. Next step, I take the next decision tree 2, and trains it with the X2 sample, and m times. And next step, you just, for example, in regression task, as I said, you can take mean value for your predictions. And very shortly explanation, you give n amount of some algorithm, train it with bootstrap samples and parallel, and then you some with some aggregation function create the final result for your data. Do you understand how it works?
Yes.
Okay. Let's try to discuss the bias variance trade-off. It's some not simple conception, but I'm sure that you understand it. All error for your model consist on bias, variance, and some noise. Noise is just part of error, and it always we have. But other parts for your model error is bias and variance, and you can change it and influence on it. What is the bias and what is the variance? When your model have height bias, it means underfitting. That when your model when your model has height variance, it means that your model overfitting. Why it and how it understands? Let's imagine that you have a model, and when you then you have a height bias, is error which happened because of your model very simple. Your model very make your task more easier, and it's very simple model for your task. And because of these reasons, target for this model will vary so far for real target value. What about variance is error which happens when your model very very changeable independency of your data. For example, in this case, in this case, we some change our data, but prediction of our model is changed. And your model can start remember this data, and when you give for your model some new data, it couldn't be to define correctly just because your model overfitting. And yeah, this problem called bias variance trade-off, because you need to find the compromise between bias and variance. Perfect model is model that has low bias and low variance, but it's impossible. You need to catch the balance between these definitions. And when you use only one decision tree, it's effective not enough, and it's really difficult for choosing the optimal parameters, because overfitting and underfitting, no, I think more overfitting, it's a really big problem for decision tree. And we discussed Ansible conception. So we can try to use amount of some amount of decision tree, like in this example. Let's try to take some amount of decision tree, and cause of you take some decision tree, every tree try to fix and mm, fix the problem another trees. And it's something like compensate, because your first tree has error, and the second tree has error, but um, they can compensate each other. So in next part, we will discuss very strong Ansible algorithm, but now we can describe and consider baking algorithm. In next part, we will discuss boosting, and it's more serious and more strong algorithm. But the random forest, if you know some competition platform Kaggle, do you know about Kaggle?
Yes.
Yeah, on the Kaggle random forest and different modification of boosting algorithm usually use for good result in competition. And I know many cases then people win with Ansible algorithms and random forest and boosting too. Okay, now we can load some real data. Let's try on this file. Okay, we have state, count, area code, international plan, voicemail plan, and lots of features. And we want to split our data on some fault. We divide our data on 5 faults. And we will use random forest classifier. Let's try to check the documentation. One of the most parameter for random forest classifier. As you understand, random forest classifier is just Ansible with decision tree. If you see one tree and then you go to forest, and in the forest lots of trees. I think it's really simple conception. And one of the most parameter is n estimators, is a parameter which shows how many trees in your forest. And let's try to train this algorithm. Okay, we also comparing this with the logistic regression. Okay, let's see on random forest classifier. Now we want to choose optimal parameters, and we want to first choose number of Ansibles. Then we want to choose maximal depth for your trees in Ansible, then it's minimal samples in your leaf. And okay, let's try to do it. If you use your algorithm without specific parameters, as I said, def and minimal samples in leaf, it's very important parameters. You see that your model just overfitting. On train set, you get accuracy 1, and of course it's impossible situation, something unrate. And you want to choose maximal depth for trees and minimal samples in your leaf. It's different values for your Ansible, max depth trees in your Ansible. And in this cycle, we just change these values for understand which value will good for our task. The max def parameters really good can really good regularizate your model, and they see that with this parameter our model over less overfitting. Also, regularization parameter is minimal sample sleeve. In this case, we don't win in validation accuracy, but we can decrease our overfitting, saving the accuracy approximately 92%. And at the end, we can okay, sorry. Also, we have max features parameter. It's a number of features for dividing data. And at the end, we can understand which combination of parameters give the best result and which estimator is the best in our experiment. You see that the best parameters for your random forest classifier is max depth 20, max features 10, mean samples leaf 3, and yep, you give the score 96%. Now you can see the bagging classifier. We discussed that bagging one of the Ansible algorithm and discussed how it works. We just train in parallel decision trees and use some aggregation function for every prediction from your trees. And in bagging classifier, we can also choose parameters. So in this case, we change in cycle number of estimators, and in this case, we choose maxdef 7, maxdef 14, and you can see how change result in dependence on this parameter. And I think the last thing today is out of bag error. What is it? When you make bootstrap sampling, you every iteration use some random uniform data. But in experiment results, we understand that in bootstrapping samples, only 63 parameters from all data. And out of bag error, it's some ways for estimate error of model using data which we don't meet in bootstrap samples. This way, with this approach, we can estimate error model without specific validation sample. So yeah, you just 63% in randomly sampling. So you can use other 37% for checking your algorithm. I think is all information on today. And next lessons we will discuss boosting algorithm. And I hope that today my colleague will send homework for your graduating. Thanks for lesson. Have a good evening.